Hey guys, it's Jeff here at Metalworks. So I said I was working on a welding video, and I am. Unfortunately, it's a lot of information to get across, and it takes a massive amount of editing, so I'm still working on it. But at the end of the day, I still have to build these things, so I can only work on it so much. I do have a couple minutes though. I figured I'd start doing some tech tips. At the end of the day, I'm doing this because a bunch of people ask me questions, and hopefully we can get some more information out there that's gonna help some other people build what they want to build. So in an effort to do that, like I said, I'm going to try to do some tech tips. So for today's tech tip, we're going to be talking about gussets, whether it be in a roll cage or a chassis. But for example, we have this chassis, right? And yes, it's insanely strong. We have all of the triangulation in the back here, and the roof. It's, like I said, it was designed insanely strong, but at the end of the day, it's only as strong as where the tubes join together. So one thing that we do to help strengthen that is going to be to start putting gussets in. Typically like to see one up here at the top of the B pillar where it meets the roof bar. I always do one down here where the A pillar connects, whether it be out here on the beltline bar or over here on the front dash bar. And I always like to see one up here on the windshield bar to the A pillar. Yeah, we have the A pillar support that goes all the way down here to this node to stop any type of vertical impact, but still the idea is to strengthen this connection here between the windshield bar and the top of the A pillar. So one thing that people do, and this drives me absolutely crazy, is they will use plate style gussets. It's quick, it's easy, and quite frankly, it's the lazy way to do it. Okay, so what they'll do, they'll take a piece of plate and they'll stick it in here just like that. And the idea is, what's a gusset do? A gusset helps to distribute the load. Load comes down the tube like that, and instead of going into just that welded joint, the gusset helps to distribute that load over an area that's this big instead of an area that's that big. The problem with plate style gussets is now all that load is going to be applied in a very, very narrow area of the tube. When a huge impact occurs, that plate style gusset, where it is welded here and on the other side, because we're going to do things right and we're going to weld both sides, it's going to rip that tube apart. So that's what we call a can opener gusset. I don't know why major racing organizations still allow them, but they are called a can opener for a reason. Once there's a huge amount of force applied to that, it will rip the tube apart, which now we're a lot weaker. So we tried to make it stronger, and actually we made it worse. So how do we fix that? Well, we get rid of that and we use a piece of tube. Now we have a tube style gusset. So as the forces are applied, down this tube and here, now those forces are going to be applied over the same amount of area, but those forces are going to be distributed a lot more evenly. There's going to be a lot more weld area around the circle than there is just a flat plate, and it's going to distribute those forces a lot more equally, and it's going to be stronger. It's not going to allow the tube to rip apart. So it's simple. You just take a piece of tube, put 2 notches in it, slide it in there, weld it up, and now you're safer. So how do we make this? Well, first things first, we should have a tube notcher, because we're not gonna be doing any type of fabrication work without a tube notcher. So we take the tube notcher and we do a little bit of math. I understand your desk was probably in the hallway when you were in high school. It's not complicated at all, okay? So what are we doing? We're making triangles, that's it. So here's a triangle, right? What do we know about triangles? That angle, and that angle have to equal what? 180 degrees, right? So since I designed this, I know what the layback of the roof is. It's simple. You get a angle meter, whatever you need to. You should have something like that laying around if you're building this stuff anyway. So point is, find out the first angle, right? I know that this is 50 degrees, okay? So what's 180 minus 50? It's 130, okay? So these two angles are going to equal 130 degrees. So what's 130 degrees divided by 2? That's 65. Okay, so here's the hard part. We're using the tube notcher. We're not coming off of 0. Okay, so coming off of 0, this would be 65 degrees. This would be 0, and we're looking for 65 degrees. The problem is the way the notcher works, we're not coming off of 0. We're coming off of 90. So we take the 65 and take it away from 90, and that gives us 25. Now we have a 25-degree angle there, 25-degree angle there, and then boom, we have a perfectly fitting tube gusset that is a lot stronger. As long as you aim for that backbone right there to be somewhere between 2 and 3 inches, you're going to have a very, very strong tube gusset, and it's going to work a lot better.